Hi everyone, welcome back to my YouTube channels, and in this video I'm going to share my learning notes about Kanban metric essentials, an important metrics that we can use to improve our Kanban flow. For this learning, we are going to use this board as an example. This is a typical Kanban board for software engineering team, where the flow is from the left, from to the column, move to the right until done. The first metric that we are going to explore is cycle time. Cycle time is the time between when a task starts and when a task finishes. So in our case, it starts when the task moves to development until it's moved to done. So in Jira, because I'm using Jira, I can read about these metrics with control chart reporting tools. In Jira control chart reporting tools, they offers a lot of informations that I'm going to share with you right now. So the circle or the dots here represents an issue, right? And then the y-axis is the elapsed times in days, and this is the date. So the red line is average cycle time. The blue one is the rolling average, and then the blue is area is your standard deviations. So it represents a distance between your rolling average and then your average line right there. And then if you click one of the circle here, you can also see a time span in each status for each task. Right, you can find more detail about this reporting in the Atlassian documentations. So in the next slides, we are going to see how to read this reporting. But first of all, I want you to focus on one of the tasks over here, because this task span about 200 days, which is an outlier. So let's take a look what is an outliers. So an outliers, it's important because it affects our visibility of the reporting. What we have is avoid to have many outliers, because they can deteriorate the efficiency of the Kanban flow, right? It moves your standard deviations wider. So what we want to have is to investigate the outliers and reduce them in the future if possible. So this is an example. Let's say the assignee of the task is somehow unable to continue the developments, or maybe there is an unforeseen issue like bugs or system failures happening during the development process, or maybe it's about a task to debug something that's hard to debug, or maybe it's about a research task. So for this kind of task, like this, this is, I think, we cannot avoid it, right? So maybe for this special case of task, we can exclude them from the report. But for the first example, maybe we can have a better handover process or something like that to reduce the outliers. The second analyzation is about efficiency. What we want to avoid is to have the rolling lines above the average lines, because it means that the process somehow slows down. So this is what we want to have when the rolling average is close or above the average line. It means that the throughput is increasing. So we have to check what is the bottleneck. A bottleneck can be unclear definitions of the ticket that can lead to confusions and slow down the process, or maybe the task requires high degree of technical expertise. The next analyzation is about predictability. So if you see that you want to avoid wide standard deviations because it reflects a bad predictability of cycle time. So what we want to have is a narrow standard deviations, as close as much possible with your rolling average lines. So if you're able to achieve that, we can use this cycle times history in the past to plan for capacity in the futures. For example, because of the standard deviation of the team is narrow and consistent, the team can plan for OKR timeline and capacity with the help of the Kanban cycle time report. The next matrix is throughput. The throughput matrix measures the speed at which tasks are being finished. With throughput, the team can understand how much work is being accomplished and how the tasks are prioritized. To calculate the throughput, you need to pull this kind of data. The first one is the working days data, like this. Right? So for this example, I have 1 year data. And then this is the working days for each month. And then after that, I sum the tasks that done in each month, the bug tasks that done for each month. And then I calculate the average throughput per day by summarize tasks and bugs, and then divide it by the number of working days. And then we have average throughput per day. And then we also have bug per task ratio, which is I calculated by this one, type of bug task divided by the type task. Then you have the bug/task ratio. You can use also story points. So it's up to your team. If you use story points and story points is essentials, you can also include story points there. And then from that chart, you can create a graph like this. This is a graph of average throughput per day in 1 year. So later, we can see how to analyze this graph. And then you can also have this graph where you can visualize number of bugs and number of tasks for each month in that 1 year. So let's analyze. So first is about efficiency. If you see the average throughput per day or number of the tasks being done in 1 month, the trend is decreasing. That you should careful, right? Because it means that the throughput is decreasing. So you have to investigate what is the bottleneck, because the goal is to increase the throughput. Either your tickets is slowing down in the middle of the process, or the review process slowing down, etc., etc. Later we will look how to look into that in more detail later. And from that data, we can also calculate quality. So since now we have the trend of bug tasks, it means that if the bug task trend is increasing, the quality is decreasing. So we want to avoid that, right? What we want is to investigate the reasons for increasing quality. Is maybe you add more test cases, add more automation tests, and etc. etc. And then the next analyzations that we can do with the throughputs is about predictability. So let's say I have 10 tasks that we need to plan, and then from the previous data that we have, we are able to have 2.1 tickets per day, right? That's our average throughputs. But we also have 0.1 bus per task ratio. So how we calculate the predictions? So we calculate by using this simple formula. So as you can see that we can calculate the estimations in days by this formula. So planned task times average throughput, and then we sum it with planned task times bug per task ratio. So for our examples, planned task is 10, and then we multiply with 2.1. That's our average throughput, plus 10 and then times 0.1. So we have our estimation day is 22. Okay, so 22 days to finish 10 tasks. That's our predictions based on our historical data. So this is just an estimation, so the predictions will be more accurate if our standard deviations is small or consistent, right? So it's better to have estimations like this to estimation prediction like this to estimate your plan in the futures. The last metrics that I want to share with you is flow efficiency metrics. It is metrics where we measure the efficiency of Kanban flow by dividing the number of active times by cycle times. And in addition of these metrics, I want to calculate every time spent when the team members doesn't work on anything, right? When they are waiting, because active times here means that when member is actively working on a task, right? It excludes waiting times for review, resolving blockers, and etc. etc. So that's why I propose to add a new column. I introduced a block or on hold column like this. So the idea is when a team member start their developments, but then they facing some blockers or on hold for any kind of reasons, they move it back to block or on hold, right? They should not move it to do, but they move it back to block on hold. And then if the blockers is unblocked, they continue to development process. That's the idea. Then from here, we can pull the data like this. Basically, you need to pull cycle times, and then you have active times. So active times, you get it from the status that you have where your team members actively working on, right? For our case in our demo here, it's just the development status. But if you have more than one, you have to summarize them. And then after this column, basically I put every time spent in each status. So if you're using Jira, you cannot do this out of the box. You need to use their search API, and then you have to calculate programmatically there, so it's not available out of the box. And then from here, you can play around with the data. You can summarize them, and then you can calculate the average, take a look at the percentiles. But I want to focus on this one, the flow efficiency, right? This one over here if you remember the calculation, is by dividing the active times with cycle times and then times 100%, so we can have the percentage value. I put it red because it's low, 10%, right? 10%. Because this one, the cycle times is, the summarize of cycle time is 171, but the active times is only 18 days, so it's pretty low. So I challenge you to think from that example, what does it mean to have a low flow efficiency score, right? It means that a low flow efficiency means that we have a lot of inactive times, right? Engineers or team members doing nothing. Why? It can be a slow review process, right? You can take a look at with the summarize of time spent in review columns. We have that data. If it's slow, then you have to figure out why it's slow and then what is the solutions. And then, oh, it's blocked too long. So you have to investigate what are the blockers and how we can unblock it faster. And then what does it mean if tasks stay at to-do column too long? Oh, maybe we are over planning, right? Or maybe we're actually not over planning because that's the actual task that we put, but maybe it's because the development time is slower than usual. So you have to again investigate retrospective with your teams, why it's slow, right? Or why it's over planning, things like that. So the key point here with these matrix, and then later you will analyze, right, is that a continuity of improvements through retrospections, right? So you have the tools now, which is the data, which is the metrics, to start your retrospections, right? And then from there, you keep improving your Kanban flow, you keep improving your throughputs, and then you keep unblock the blockers, make the flow flowing like a river. Anjay. Yep, thank you for watching me, and I'll see you around in the next video. Keep learning and stay healthy. Bye bye.